Hello student, welcome back to the course on optimization methods for civil engineering. So, in today's class we will learn about Matlab. So, basically it is an introductory lecture on Matlab. So, I will show you how you can register on Matlab or how you can work on Matlab, how you can write a simple equation in Matlab. So, that actually I will explain in this particular class. Now, what is Matlab? So, Matlab is a high performance language for technical computing. It integrates computation, then visualization and programming in a easy to way environment. So, already you have learned R programming. So, Matlab is like R, Matlab is also a programming language. So, it is a package basically. So, and easily you can do lot of programming here. So, we generally use Matlab for maths and computation, algorithm development, data analysis, exploration and visualization. So, we can also visualize the data, we can analyze the data, we can also do modeling, then simulation and prototyping, then we can also use for scientific and engineering graphics. So, it has a very strong graphical package. So, we can also use for application development including building GUI graphical user interface in Matlab. So, we can develop graphical user interface in Matlab. Now, let us see how you can download Matlab or how you can work in Matlab. Okay. So, in the next few slides, so I will show you how you can register in Matlab online in a stepwise manner. Okay. So, in next few slides, we will learn to use Matlab online in a stepwise manner. So, to do that, so you have to go to this particular website, that is in.mathswork.com. So, once you are going that one, so this is the website. So, you have to go to this particular website and here you can register or you can create a account in Matlab. So, you click on this particular icon. So, this icon. So, you in this icon you click to get the Matlab icon. Now, here, so if you have already an account, so you can write your email ID and then you can give your password, or otherwise you create one. So, you just click on create one. So, you can create an account. So, if you already have a MathsWork login, then put it, otherwise you go to create one. Now, here you give your email ID and then you give your location, then you give your for what purpose you would like to use. Suppose you are a student, so you just write a student, or otherwise I am a teacher. So, I will write teacher and research in academia. So, here you have to select whether you are 13 years or older. So, you select yes here and then you create, and then a account will be basically a link will be sent to your email ID. It is showing that a link has been sent to your email ID. Okay. So, to your email ID, and after clicking on create, you will move to this particular page which will ask you to verify your email address. So, you have to verify your email address and you go to your email ID and you will get a link for verification. So, this is the email I have received. So, here you just write verify email. So, once you have verified your email ID, and then you have to put your details. So, you have to put your first name, last name, then you have to choose one password, then confirm password, and then you describe your roles, and finally, if you have any activation your key. So, you can write it here, or otherwise you leave it. So, you go to you accept here and then go to create. So, that will create an account, or you create a login credential on MathsWork. Okay. So, you have to accept the online service agreement and then create your login credential. So, after that, so you just see, so I have created an account. So, now this is my account. So, I have login and then you just click on this particular 9 dots. So, there are 9 dots and you click here, and once you are going, so you can see this is the Matlab. So, now if you have the license already, so you will get your Matlab, or otherwise you can also use the free version. So, 1 month free version also you can use. Okay. So, otherwise you can go to directly you can go to Matlab. So, then so I am running Matlab online now. So, I am getting this particular interface. Okay. So, you can see here, so there are so many things. So, anyway, so you need not learn all those things today, but what I can do, I can create a script using this one. So, this is the new script, and then you can open a file. Okay. So, you can open a file from here, and there are lot of windows here. Suppose this is showing current folder and this is workspace. Okay, and this is the command window. So, you will get this particular your interface. Okay. So, we will learn one by one what is this interface. So, we have used here the default your layout. So, you have different layout version, but I have used here default layout. So, you can choose layout of your choice, but I have used here default layout. Okay. So, in the default layout, so I am getting this particular windows. So, one is current folder, one is workspace, then script window, and one is command window. Okay. So, the first one, this one is your current folder. So, here all the files of this particular folder will be shown. Then the second window is the workspace. So, here you will get the name of the variable and then value, size and class. So, you will be getting here, and this is the script window. So, here this is 3 is the script window. So, I can open a script, or I can open a M file, and I can write the code, and the fourth one, so will be the command window. Okay. So, here actually you can run your the function, or you can run the commands here. Now, what you can do, so first you have to select the drive where you want to store your file. So, I have used here the Matlab drive, so where my files will be stored. Okay. So, from here you can select the drive. So, here I can use, so I have used Matlab drive, or you can also create the another your folder and where you can store your file. Now, let us see how we can open a script or open an M file. So, for opening an M file, so what you can do, you can use the open buttons here. So, you can use this one, or if you want to create a new script, so you can use the new script, this button. So, you can create a new script, and if you want to save that one, so you can use the save button, or otherwise I can also use the this edit command to open an M file. Suppose I would like to open this average M. So, what I will write, so I can either open from using this button, or I can also write edit average. So, this file will be open. Okay. So, now is a C. So, here I have shown all the 4 windows. Okay. So, this is the window 1. So, you can write a script, and here I have opened a file introduction Matlab 1.m. So, this is the script I have opened, or this is the name of this particular file, and you can see this script has been opened here. And here, so you just see, so these are, suppose if I want to clear the command window, so I can write CLC. So, if I write CLC and execute this particular one, this particular window will be clean. And then clear variable, so here all the variables will be clean. So, if I write clear variable, okay. And then here I have assigned that A is a variable which value is 20 and B is a variable which value is 20, and C is equal to A plus B. So, you just see it is very simple. So, I have assigned 20 to A, then 20 to B, and then I have executed this particular line to get the value of C, which is equal to A plus B. So, therefore, what I should get? I should get 40. So, if I execute this particular M file, so how to execute that one? By clicking on the run button. So, I can just click the run one, and then this file will be executed, and I should get the value of C, and that is 40. Now, you just see, I would like to mention here that I can write A equal to 20. So, then what will happen if I execute this particular line, then here in the command window, so you will be getting that A equal to 20. Okay. And if I put this colon, semicolon, so what will happen? Then you will not see this particular variable here. Okay. So, in the command window. So, here if you look at it, that after A, so in this particular line 4, I have put semicolon here, then a semicolon here, but at C in this line 6 I did not put any semicolon. So, therefore, the C will be display here, that C equal to 40. Now, as I have shown here, the Windows 1 is the script window. So, here I can write the M file. So, just like the R programming. So, already you have learned the R programming. So, there also I can write the script, and then I am running that particular script. So, here also, here in Windows 1, so I have opened an M file, and I have written this particular code, and this code can be executed using the run button. And in the command window, once you are executing that one, so you are getting C equal to 40. Okay. So, in command window you can see that this has been executed, and if I write the other command, suppose I would like to see the version here. So, this is the version of this particular MATLAB. So, the version is this is R2021A, the version is R. So, this is R2021A. Okay. So, this is the version of this MATLAB. Now, you just see in the window 3, so here you will get the workspace. Okay. So, we have how many variable we have? So, already we have A. Now, here what is the value of A? The value of A is a scalar, and value of A is 20, and size in MATLAB actually either it will MATLAB it will store as an array. So, size is 1 by 1, though it is a scalar, but it will store as an array, and size is 1 by 1, and this is your class is double. Similarly, the version I have executed. So, this is actually as a character it has been stored, and B is again a scalar quantity, but it has been stored as an array 1 by 1, and this is double, and C is 40, and it is 1 by 1 array, and this is double. So, by clicking here, so you can see that this is the value of suppose A. So, you can see the value of the variables. And in this particular window, so you can see the files we have. So, we have the file introduction MATLAB 1. So, this is the M file. So, you can see in this particular window. Now, let us do some basic calculation in MATLAB. So, as you have seen, so we have already learned R. So, there also we did some basic calculation, and this is almost similar. Okay. So, this is similar the way you have written a particular your equation or particular function. So, we are also writing the similar way in MATLAB, though there may be little bit of though the syntax may be little bit different. So, let us see. So, here in case of R, so a variable was assigned like this. So, I can assign that A equal to 20, or I can also write A equal to 20. So, in MATLAB you cannot use that one. So, this is not acceptable in MATLAB. So, what you have to do, that A equal to 20, B equal to 20, and C equal to A plus B. So, this is correct, but I cannot write that A equal to 20, B equal to 20, and C equal to A plus B. So, this is not permitted here. So, you cannot do, but what I can do, so I have assigned A equal to 20, B equal to 20, C equal to A plus B, and if I put that a equal to 20 colon, that means this will not be displayed at the command window, but if I write a equal to 20 and execute this particular line, so then here it will be displayed. Okay. And once I have executed this one, so you can see this is the file I have, the introduction matlab1.m, and I have 3 variables here a, b, c, and size is 1 by 1, 1 by 1 and 1 by 1, and class is double. Okay. So, if I execute this particular file using the run button, then I will get the c equal to 20. So, if I start a particular line with percentage, okay, so this percentage, so this is meaning that this is a comment line. So, if I write it that this percentage, okay, then assigning a value to a variable, so this is the comment. So, in case of R, we have used this hash to define that a particular line is a comment line. So, if you are writing hash, that line has not been executed, but in case of MATLAB, so what I have to do, we have to use the percentage symbol. So, then this will not be executed and rest of the lines will be executed. These 5 lines will be executed and I am getting the value here. Now, let us see how MATLAB behaves with the data vector. What happens when a scalar is added, subtracted, multiplied, divided in a data vector. So, already we have learned this thing in R. So, let us see how we can do this calculation in MATLAB. So, let us define a vector here. So, here a vector is defined using this bracket. Okay. So, x is a vector and the value of this vector is 1, 2, 3, 4, 5. Okay. So, if I execute this particular, so I am getting this value. So, now you just see this is defined as an array. So, as I said that in scalar also it is defined as an array. So, in case of scalar it will be 1 by 1, but here it is a vector and now you just see this is 1 by 5. Okay. So, that means 1 row and there are 5 columns. Okay. And you can see the value here. So, you can see the value. So, this way I can define a vector. Suppose I would like to define a y vector. So, this is I can also write like this that 2, 4, 6, 7 like this. So, I can give the comma here or without comma also I can write that one 2, 4, 6, 7, this is also acceptable. Okay. So, or either otherwise I can also give the comma. Now, let us see that I would like to add a scalar with this particular vector. Okay. So, vector here is 2, 5, 6, 7. So, this is a vector and with that I would like to add 3. Okay. So, this is addition in data vector, that is x plus y. So, here this is an x and this is your y. So, in that case what will happen? The 3 will be added to each element of this particular vector. So, 2 plus 3, then 5 plus 3, 6 plus 3, 7 plus 3. So, I will be getting, you just see 2, 5, 6, 7 plus 3. So, I got this particular x vector. Similarly, if I write that there are 2 vectors, the dimension has to be equal. Suppose this 1, so the dimension is 1 by 4 and here also it is 1 by 4. Okay. So, that means I am adding these 2 vector, then the corresponding element will be added, that is 2 plus minus 2, then 5 plus 6, then 6 minus 7 and then 7 plus 1. So, I am getting this particular y vector. Okay. So, this, but you just see that this dimension has to be equal, that means same dimension. Now, what will happen if the dimension is different? So, in case of R, you just see this has been executed. Okay. But here what will happen? This is 1 by 4 and this is 1 by 2. So, in that case you will get this particular error. Okay. So, this is an error in this particular line, line 4. So, there is an error and this dimension has to be equal. Okay. So, you will get an error if the dimension are not matching. Now, if I multiply a particular vector with a scalar. So, here I have multiplied this particular vector 1, 2, 3, 4 okay, by 2. So, what will happen that 1 into 2, 2 into 2, 3 into 2, 4 into 2 and 5. So, there is another one. So, 5. Okay. So, you are getting this particular value 2, 4, 6, 8. Okay. So, anyway this 5 is not there. So, if you are putting this 5, then you will get another one, this is equal to 10. Now, let us see if I would like to multiply the corresponding elements. So, that means I have two vector, this is x. So, x is a vector, this is 1, 2, 3, 4, 5 and there is another vector y and this is 5 minus 4, then 3, then 2, then 1. Okay. So, this is another vector and what I would like to do that I would like to multiply the corresponding element, that means 1 into 5, 2 into minus 4, 3 into 3, 4 into 2 and 5 into 1. So, then I have to use this one. So, what do you have to do? So, I would like to suppose z and which is equal to x star y. So, you will get an error. So, you have to put a dot here. Okay. So, this means that the corresponding element will be multiplied. So, you just see I have written here. So, this is dot into star. Okay. So, you have to put a dot, then in that case this will be executed. So, this line is not there. So, this is the cursor actually. So, this line you just remove, this line is not there. So, this is 1, 2, 3, 4, 5 and then dot and then star and then 5 minus 4, then 3, 2, minus 1. Okay. So, then you should get this particular result. Now, what will happen if these dimensions are not matching? Okay. So, in case of R, so you will get some result, but here you will not get it and you will get an error. Okay. So, because these dimensions are not matching. Okay. And dot is also not there. So, if dot is there, then corresponding element will be multiplied, but you will get an error in this case. So, this dimension has to be equal, that means if it is 1 into 4. So, here it is 1 into 4 and this should be 1 into 4. Okay. So, then only this line will be executed. Now, if you are dividing a particular vector by a scalar here, suppose I have divided this particular vector. So, this particular vector with this scalar and scalar is minus 4. So, what I have done here, this is x which is equal to 1, 2, 3, 4, 5 and then I have divided it by minus 4. Okay. So, in that case you are getting this particular answer, that means corresponding element will be divided. Now, if suppose this is a vector and this is also a vector. So, and if you are not putting dot, so in that case this will be your result. So, you will get 1 and this vector has been divided by this vector. And if I want to divide the corresponding element, so then what you have to do? So, you have to do, so I have defined x here, x equal to 1, 2, 3, 4, 5 and then y equal to x dot slash x. Okay. So, in that case corresponding element will be divided, that means, so 1 by 1 you are getting 1, 2 by 2 you are getting 1, 3 by 3 you are getting 1, 4 by 4 you are getting 1, 5 by 5 you are getting 1. Okay. So, this is the results you will get. Now, if you want to calculate the power, okay. So, here what I am looking for, that I am looking for 1 to the power 1, then 2 to the power 2, 3 to the power 3. So, in that case you can use cap, but you have to use a dot sign also. I have not used here. So, therefore, I am getting this particular error line. Okay. So, this particular error I will get, but if I put this dot, okay. So, here what I am doing, this is 1, 2, 3, 4, 5, okay. And then dot cap I am using, then this is 1, 2, 3, 4, 5. Okay. So, then you are getting 1 to the power 1, this is 1, then 4, 27, 256, 3, 1, 2, 5. Then like R, Matlab is also having the inbuilt various inbuilt function. Okay. So, here you just see some of the function that if I would like to calculate absolute value, suppose if I write a b as minus 5, so I will get plus 5. So, a b as suppose 10, so I will get 10. Okay. So, absolute value you can calculate, then SQRT you can write square root, then round, floor and this is ceiling. Okay. So, round means suppose if I write round 2.2, that means what you will get? You will get 2. If you write round 2.7, so what you will get? You will 3. Okay. So, that means if it is more than 0.5, so you will get the higher one, or otherwise you will get the lower one. Okay. But if you are using floor, okay, so floor 2.2, then you will get 2, then if you are using floor 2.7, then you will get 2. And if you are using ceiling, here CEIL, okay, and if you are writing 2.2, then you will get 3, and if you are writing 2.7, then also you will get 3. Okay. So, this is rounding up and down. So, these functions are similar to what we have learned in R, and similarly I can use sum and product, then I can use log, I can calculate the logarithmics, and exponential function exp I can write, then trigonometric functions sine, cos, tan, a sine, a tan, okay, a cos, that you can use, and mean and max. So, this is similar to your R. Okay. Max and mean I can use, getting maximum from a vector, getting maximum and minimum. Okay. Okay. Minimum from a vector. Suppose if I write that x equal to 1, 2, 3, 4, 5. Okay. So, if I write mean x, so I will get 1. If I write max x, I will get 5. Okay. This is the 5 is the maximum of this particular vector. Then if I write pi, so I will be getting this is pi, then infinity. So, it's use I and f, then not a number I can use nan. Okay. So, not a number. So, this is predefined constant value. Then like R, so I can also use the logical operators for logical comparison. Suppose these operators are greater than, so I can use greater than equal, then less than equal, then equal and not equal. So, not equal I will be using this one. Okay. So, it is basically it will return whether this is true or false basically. So, true or false it will return by this operator. Now, let us see a matrices. A matrix is a collection of data element arranged in two-dimensional grid, row and column. So, in Matlab everything is defined as a matrix. Even I can write a scalar which is 20 and actually it is defined as a matrix. This is a 1 by 1 array. Okay. As with the vectors, all the elements of a matrix must be of the same data type. So, it must be of same data type, and a matrix can be generated by several ways. Just like R, we can generate the matrix in several ways, and matrices are fundamental to Matlab. Okay. So, actually it is coming matrix laboratory. Okay. Matlab is means matrix laboratory, and therefore, we need to become familiar with matrix generation and manipulation. Okay. So, this is we should learn, because this in Matlab all that means of data is generally we define as a matrix. Now, how to generate a matrix in Matlab? It is very easy. Okay. So, you can see I would like to define a matrix. This is the variable A which is a matrix, and this matrix is, so if I write 1, 2, 3, 4, that means, and then suppose I would like to, this is the matrix I would like to define 1, 2, 3,
then 4, 5, 6, then 7, 8, 9. So, what I will do? I will write like this. This is 1, 2, 3, okay. Then 4, 5, 6, okay, and then 7, 8, 9. Okay. So, you have to either you have to give comma or you have to give a blank. Okay. So, you have to give either you have to give comma or you have to give a blank. Okay. So, now if I execute this particular line, so I will get this particular matrix. The matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9. So, it is very easy to define a matrix, and a vector you can define, suppose 1, 2, 3, 4, 5, 6. So, this is a vector. Okay. So, either you can. So, this is a vector, and once you are defining matrix, so second line I can define like this. Okay. So, I can use the semicolon. Now, if I want to calculate the transpose of a matrix, okay. So, here I have defined A. So, A is this is 1, 2, 3, then 4, 5, 6, 7, 8, 9. So, this is a matrix. So, now I would like to calculate the transpose, A transpose, which is this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So, what I will do? I will use this symbol, okay, transpose symbol. So, I will get this matrix. So, A is now transpose of this one, and this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if I would like to create a matrix of ones basically, okay. So, I can use ones to create, suppose I would like to create a matrix, this is A 1 1 1 1 1 1 1 1 1, okay. So, what I have to do? So, I can write that A equal to 1 once, this is 3 comma 3, okay. So, then a matrix will be created of 1, this is 1 1 1, all elements will be 1. So, I can use 1. Similarly, I can write suppose zeros, if I want to create a matrix zeros, and this is suppose B, which is zeros, okay. This is 3 3. So, what you will get? The B will be like this 0 0 0 0 0 0 0 0 0, okay. So, this will be your B. So, here I have shown you that A is an array. So, this is I have created with ones, that means all ones, okay. So, this is your A and this is your B, B all B is an array, and this is 1 by 4 and elements are 0, and then I have added this A and B, okay. So, I have written A and basically B, okay. So, what is happening? It has added A B, okay. So, then I have printed using C. So, you can see this one, and then now if I want to write on the second line, this is A is 1 all 1 1 1 1 1 and B is 0 0 0 0. So, in the second line then I have used this semicolon, okay. So, I am getting this particular array. Now, I can use the display A. So, to display a matrix, suppose in this case what I have done, I have created a matrix, and this matrix is 1 2 3 4 5 6 7 8 9, okay. So, this is the matrix I have created, and this matrix is I have displayed using this display function disp A. So, it has been displayed here. Now, what I have done, that the third row, okay, all elements, that means this particular third row all elements. So, what I have done, I put this is equal to 0, that means this particular row is 0, and then what I have copied it and in C. So, C equal to A and display C, and you can see that third row is now 0, okay, all zeros. So, there are some other function I can use I, this is it will return an m by n matrix with 1 in the main diagonal, okay. So, what I would like to do, basically in the diagonal I would like to make it 1, okay, make it 1, and then I can use this particular command I m into n, okay. So, it will create this is m into n. So, this is the row and this is the column, and if I write I n, so then it will generate a square identity matrix. Okay. So, it will generate a square. Suppose if I write E y E and this is 3. So, it will generate 1 0 0 0 1 0 0 0 1. Okay. This is 3. Okay, I 3. So, this will be generated. Now, as I have shown you that I can write zeros. Okay. So, it will create m by n 0 matrix. Then once I can do that, so it will create m by n 1 matrix, and I can use diagonal A. So, it will extract the diagonal values, and I can also generate random number using this particular function ran m by n. So, it will create a matrix, okay, and the elements will be generated randomly, and the matrix dimension will be m by n. So, let us see that. So, here I have shown that I 5. Okay. So, this is a 5 by 5 matrix. So, you can see all diagonals are 1, all diagonals are 1, okay, and off diagonals are 0. And if I create, if I just write I, this is 3 comma 4, okay, 3 by 4. So, it will create 3 rows and 4 columns. So, and all diagonals will be equal to 1, and if it is I 3 by 2. So, this is diagonals will be 1, off diagonals will be 0, and this is zeros 3 by 2, then all zeros. So, this is a 3 by 2 matrix, and similarly if I write ones 2 by 3. So, this is a 2 by 3 matrix, and you can see all you are getting ones. And then I have created this particular matrix. So, x equal to 1 2 3 4 5 6 7 8 9. So, this is the matrix I have created. This is the matrix I have created, and I would like to get the diagonal elements, that means 1 5 and 9. So, I will use that diaz x. So, I am getting the diagonal values, this is 1 5 and 9. And if I want to create some random values, okay, and this ran function will create a matrix, and the elements has been generated randomly, okay, between 0 and 1, and you can see. So, I am creating a 2 by 3 matrix randomly, okay, and these values are between 0 and 1. Now, let us see matrix operation, arithmetic operation that we have already we have seen in case of a vector. Suppose I would like to add A with B, okay, and B with A. Then if I multiply A and B, then if I want to calculate the square, okay, and then if I multiply with a scalar, okay, alpha. So, what will happen? And if I want to do the corresponding, that is element by element division. So, if I want to do the element by element operation, that means then I have to put this particular dot, okay. So, this particular dot. So, this will do the element by element operation. So, it is in division, this is multiplication, and this is exponentiation. So, I have shown here, you just see this is A is a matrix. So, this is the matrix I have created using that line, and B equal to A, and then I have divided the element by element division, that is A dot B. So, I am getting all ones. And similarly, if I do element by element multiplication, so this is A and this is B, this is A and this is B, and just see this is 1 into 1. So, I am getting 1, 2 into 2, I am getting 4, 3 into 3, I am getting 9, then similarly 16, 25, 36, 49, 64, 81. So, this is element by element multiplication. Now, if I write that A star B, then what will happen? So, this will give you the matrix multiplication. So, I have created two matrix, this is A matrix and this is B, and then this is C is your matrix, that is A cross B. Okay. So, I am getting this. Okay. So, it is a matrix multiplication between A and B. Then if I want to square the corresponding element of this particular matrix. So, I have to put dot. So, in this case I am writing C A dot cap 2, that means I have square all the corresponding elements. So, it is 1 square, this is 1, 2 square 4, 3 square 9, this is 16, this is 16, 25, 36, 49, 64, 81. Now, we can also define the function in matrix. So, already we have learned how you can define a function in R. So, let us see how you can define a function in MATLAB, okay, a function in MATLAB. So, a function is a set of statements organized together to perform specific tasks. MATLAB has a large number of inbuilt functions. So, you have seen there are functions, suppose I have seen the max function, then mean function. Okay. So, these are some of the function already we have, and there are a lot of several inbuilt function in MATLAB. You have seen that round. Okay. So, this is also a function, then floor. Okay. Floor is also a function, then CIL ceiling is also a function. So, there are several inbuilt function in MATLAB, and the user can create their own functions. Okay. So, you can also create your own function, and once you have created this function, and you can use this function just like an inbuilt function. Okay. A MATLAB function is created by using keyword function. So, the keyword here is function, and the keyword is same as what you have learned in case of R, the same keyword, the function keyword you can use. The basic syntax of MATLAB function defined as follows. Okay. So, you have to use this particular keyword function, and y1, y2, yn. So, this is the value of the variables which is coming out of the function. Okay. So, these variables are coming out of the function, and then you can define a name, or you can give a name. Suppose this is my function, you can give any name of your means as per your requirement. So, you can give a name, and then these are the arguments what is coming to the function. So, what is happening, these arguments are coming into the function, then you are doing some calculation here, and these variables, okay, will go out of this function. Okay. So, I will get this particular variable after executing this particular function, and then here we are not using, in case of R we have used the second bracket, but here we are not using. So, we are writing this is the beginning of the function and this is the end of the function. So, end of the function we are writing end. Okay. So, end. So, where argument 1, argument 2 are the input, and what this function will return, the function will return y1, y2, yn. So, this is your simple, it is not difficult. Okay. Just like your R, the syntax is little bit different. So, it is not similar to R, but keyword is same. So, in R also we are using the function keyword to create a function, and here also we are using we are using the function keyword to create a function, and syntax is different. So, here the function is created using the function keyword, and then the function will end with end. Okay. So, we have to write end. Now, let us see a function. So, the function is square. Okay. The function is square, and what we are doing here. So, this is the vector I am taking. So, x is a vector and this is x, and I would like to calculate square of this particular x, and so I have written this is x into x. Okay. And I have stored here, and this y will be coming out of this function. So, now I have defined this particular function, and now I would like to calculate the square of 4. So, simply what I will do, I will write square 4, okay, square 4, then I am getting 16. Similarly, if I write squr 5, so you will be getting 25, something like that. So, this function will return the value of y. Okay, this function will return the value of y. Now, there are several your ways to implement the loop and conditional statement in MATLAB. So, let us see. So, I would like to discuss here the for loop. Okay. So, for loop, the syntax is for index equal to values, then this statement will be created, and then this loop will end by this end end. So, you have to write end. So, this is the beginning of this particular loop and this is the end of this particular loop. Similarly, you can also use while loop. Okay. So, this is I am writing while expression and then these are the statements to be executed and this is the end of the loop. And similarly, you can also use if else statements to execute some conditional your statement. So, if expression, so you will write expression then statement, then else if you write expression then statement, then else you can write statement. So, then end. So, end is basically end of this particular conditional statement. So, here let us see that how to use the for loop. This is very easy. So, what I would like to do here, that for I equal to 1 to 7, that means for I equal to 1 to 7, that means I equal to 1 to 7, that means for I equal to 1, 2, 3, 4, 5, 6, 7. Then you calculate the y and y is equal to I square and then display y. So, if you are executing this code using this run button, so you are getting that 1 square, then 2 square, 3 square, 4 square, 5 square, 6 square and 7 square. So, this is 1 to 7. Okay. So, this is if this is your for loop. Then I can also execute this one using while loop here. So, okay, while loop. So, while I is less than equal to 7, okay. So, I is less than equal to 7 while, okay. So, while this is less than equal to 7, that means it will start from 1. So, I equal to 1 I have defined, then 1, 2, 3, 4, 5, 6, 7, okay. So, and then this y equal to I square, then display the value of y, and in this case I have to put a counter here. So, in the next time I will be equal to I plus 1, okay. So, I have to write this one, and once you are executing, this is 1 square, 2 square, then 3 square, 4 square, 5 square, 6 square and 7 square. So, you are getting this particular output. So, let us see how you can write the conditional statement using if. So, if x is greater than or equal to 0, then display the number is positive. If x is less than 0, so in that case it will be negative. So, what I will do here, that if x is greater than 0, then display the number is positive, else the number is negative. So, therefore, now I put x equal to minus 5. So, therefore, this number is negative. So, this has been displayed. Now, let us see how we can write an expression. Suppose I would like to write an equation the way we have written in case of R. So, let us see how we can write an equation. So, this is just similar to the way you have written in R, okay. The similar way I can write an expression. So, let us see that, okay. Now, suppose I would like to write this single variable equation, that is f(x) equal to x square plus 54 by x. The code is anyway. So, these are something these are some command line, okay. So, and here, so this is clear the environment and clear the variables here, okay. And then these 3 lines are command lines, and then I have written f equal to, so this is I have written at the rate and within bracket I have written x. So, x is a variable here and this is x square plus 54 by x, okay. So, in this case x is a scalar. Now, if I would like to calculate what is the value of this f1 for x equal to 1 and x equal to 2. So, I can write that f1 1. So, for the value of f1 for x equal to 1 and value of f1 for x equal to 2. Now, let us see this code. So, this will be executed. So, it will clear the command window and this will clear the workspace, okay. So, this will clear, and after that this 3 line will not be executed because it has started with the percentage sign. So, therefore, it will not be executed. So, this is for comment only. Then I have written this is the expression that f of x. So, this is f1 and at the rate within bracket x, this x square plus 54 by x, and then I calculate the value of this f1 for x equal to 1 and this is for x equal to 2. So, once you are executing this particular code, so using this run button, so you will get 55 and 31. That means the function value for x equal to 1 is 55 and function value for x equal to 2 is 31. Now, let us see a different function. So, this is f of x equal to e to the power x minus 400 x cube plus 10. Okay. So, here I have written this expression. So, now this is e to the power x means e x p, this is x, okay, minus 400 star, this is x cube, okay, plus 10 plus 10. So, this is similar to what we have learned in case of R. Okay. So, this is similar, and then only thing is that this syntax is different. Okay. So, in R we have written using some different syntax. So, here it is different. Then I calculated what is the value of this particular function for x equal to 1 and x equal to 2. So, if I write this particular function, if I execute this one, then I am getting the function value for x equal to 1 is this, that is minus 387.2817, and for 2 this value is minus 3.1826 e to the power 3. Now, this is another function. So, this is another function. So, that is 2x to the power 4 x minus x cube plus 5 x square minus 12x plus 1. Okay. So, here I have written this particular function, that means that f3, okay, so which is equal to at the rate, this is x, and then this is 2 star x to the power 4 minus x to the power 3 plus 5 star x to the power 2 minus 12 star x plus 1. Okay. So, this is, and then I calculated the value of this particular function for x equal to 1 and x equal to 2, and I have written this code here, and if you are executing that one, then f3 for x equal to 1 is minus 5 and f3 for x equal to 2 is 21. So, this is very simple. So, you can write an expression or you can write an your function and you can calculate the value of this particular function for different value of the variables. So, this is a 2 variable function. The function is x square plus y minus 11 whole square. So, that is x square plus y minus 11 whole square, then x plus y square minus 7 whole square. So, it is a 2 variable function. So, what I can do here? So, I can write this is x and y, okay, and then this x square plus y minus 11 whole square, then y square plus x minus 7 whole square, and then you calculate the value of this particular function for 1 1 and 2 2. So, if I execute this particular function, so you are getting that f1 for x equal to 1, y equal to 1. So, it is 106, and for 2 2 it is 26. I can also write this particular function, I can also write it something like that. Then if I write this is f1 which is equal to at the rate, I can define this here I have defined as a scalar, but let us define as a vector, okay, and then you should get it that this is x 1, okay, this is square plus x 2 minus 11, okay, square plus this is x 1 plus x 2, okay, square minus 7 and then square. Okay. So, I can define x as a vector also. So, in that case I have to write that f1 and this is a vector now, this is 1 1, okay, and f1 for 2 2. So, I have to write 2 2, okay. So, if you execute this one, so you should get the same value 106 and 26. Now, this is another function. That function is 10 plus x square minus 5 xy plus 9y square plus y. So, I have written the function here, and this is for x equal to 1 1 and this is 2 2. Okay. So, this is 2 2, and if you are executing this one, so you should get the value of 16 and 32. Okay. So, this is x equal to, this is a vector and this is also a vector 2 2. Okay. So, you should get the value of this particular. So, this is 2 and this is 2. Now, in case of R, so we have used the AB line to draw a line, but in case of Matlab, so you can draw a line using ref line, okay, REFLINE. So, here you have to pass this particular argument, that is M and B, where M is the slope of the particular line and B is the intercept. Okay. So, I can use that one. So, here I have written my line, and my line is REF line, REF line, which is the slope is 1 and intersection is 0.01. Okay. So, you can execute this one. So, you are getting this particular line, and you can, so using this text, so you can also print the equation here. Now, if I want to draw a line which is parallel to y axis, so I can define x line. Okay. So, this is x equal to 5, x equal to 0.5. So, I have drawn this particular line, sorry, x equal to 0.56 I have used. So, at x equal to 0.56, so I have used this is 56. Okay. So, x equal to 0.56. So, I have drawn this line which is parallel to y axis. So, then I will use x line. Okay. So, x line, and then this is 0.56, and color I have used red color. Okay. So, this is x line you can use. So, similarly, if you want to draw a line which is parallel to y axis, so what you will use? You will use y line. Okay. So, y line, and I have drawn a line at y equal to 0.1, and this is also red color. Okay. So, you can use this particular function to draw a line parallel to x axis. Then if you want to plot a particular function, so you can use the plot function. So, here I have defined the value of x, and then I would like to plot this particular equation. Okay. So, this particular equation I would like to plot, and this is your plot x and f1. That means, in x axis this is x, and in y axis this is f1. So, I have used the value I have used the value of x and f1, and dimension of x and f1 has to be equal, otherwise it will not plot. So, this is the M file. So, you use a C. I have created the value, that means x equal to, so it is starting from -2, and then intervals are 0.01 and it is going up to 2, that means -2 to +2, and the interval is 0.01. And then I calculate the value of y axis, that is f1, which is equal to x. So, now I am using I calculate the value at corresponding elements. So, therefore, I have used dot, and this is x square plus 54 dot divided by x, and then I have used this plot function. Now, here this is a different equation. Okay. The second equation, that is expx minus 400 x cube plus 10, and I have plotted. So, this is x and y. So, this is x axis is x and y axis is f1, and then you can put the title. So, title is 2D line plot. So, and x level, y level you can put. Okay. So, I will write x level x. So, that means I will get x, and y level f1. So, I am getting f1. 1. Okay. So, if you execute this one, so you will get this particular plot. Now, in MATLAB, so if you want to plot, suppose I would like to plot all these graph in a single plot. Okay. So, in that case what I will use? I will use this hold on command. Okay. So, if you are using this hold on command, so that means what will happen on the same plot all these function will be plot. Okay. So, suppose I would like to plot this particular function. So, if I execute this one, okay, so this will plot the particular function, and then I have to write hold on. That means, on the same plot I would like to plot the other function. So, this is another plot and this is the scatter. Okay. So, this is the scatter and this is also I have used the blue color. Okay. So, now if you are using hold on, then in a single plot all these function will be plot, then after that you make it hold off. Okay. So, if you are executing some other line, so then it will not be this graph will not be plot here. Then if I want to plot or if I want to get a surface, so I can use surf function. Okay. So, here this is the function is x square plus y minus 11 whole square plus x plus y square minus 7 whole square. So, this is the function, and then I have used surf, and this is the function, and this is the lower bound and upper bound, and I have also written show contours. So, that means contours will be shown at the bottom. Okay. So, you can see the contour lines are here, and you can get this surface plot. So, this is quite easy, and you just see quality of the plot is also very good. Okay. So, you can just simply only 2 lines. So, I have written 2 lines to plot this particular function. So, this is another function. Okay. The function is 10 plus x square minus 5 x y plus 9 y plus y. So, this is the function. Okay. 10 plus x square minus 5 x y plus 9 y plus y, and this is also between lower bound is minus 6, upper bound is 6, and so contour on. So, you can see the contours are here, and if you are executing these 2 lines, so you will get the 3D plot of this particular function. So, I have used here surf function. Then this is another plot. So, you can see this is the plot and this is the function equation. Okay. So, this is the equation, this is x square plus y square. Okay. So, this is the equation, and once you are executing this particular 3D plot, you will get using surf. Then similarly, I can also plot the contours, and the function is contour here. So, I have to pass what is the value of x, what is the value of y, and what is the value of z here. So, in the fun, so I have calculated the value of z, and then so text on. Okay. So, text on means the contour the marking will be given. So, this is this is minus 0.2. So, this marking will be given here. Okay. So, text on. So, this is a few lines code to get this particular contour. So, this is for another function. So, I have calculated here. So, x is between minus 6 to plus 6, y is between minus 6 to plus 6, and then I have created the grid using mass grid function. Okay. So, x y you have created, and after that you calculate the function value. This is nothing but the z value at each grid point I have created, and then I use the contour function to get this particular contour. Okay. So, this is quite easy, and easily you can plot the contours. And this is for this particular function, that is x square plus y minus 11 whole square, then x plus y square minus 7 whole square, and here also. So, I created the x value between minus 6 and plus 6, and this is also y is also minus 6 and plus 6. Then I have created the mass grid, okay, and which has been stored in x y, and then I calculated the value of the function, this is nothing but the z value, and then you plot this contour, and if you are executing this particular M code, so you are getting this particular contour. So, thank you very much. So, I have introduced here what is MATLAB. So, how you can write or how you can define a variable here, then how to create a vector, how to create a matrix, and how to do the elementary operation. Suppose you want to add 2 vector, then you want to add 2 matrix, and you want to multiply 2 vectors. Okay. So, that operation I have shown here, and I have also shown how you can write a function. Suppose I would like to write a function, and that function how I will write. So, that I have shown here, and finally, I have shown you how you can plot a particular function. Suppose I would like I can plot a 2D plot, a 3D plot. Suppose using surf as surf, okay, you can plot a 3D function, and you can also use the contour to get the contour lines. Okay. So, that also you can do. So, you can use contour, you can use surf, okay, as surf, and you can also plot a 2D plot, okay, using the plot function. Thank you very much.